Left Riemann sum. So instead of using the right hand side, the right corner, and the last value, we use the starting value, and we don't use the last value. So left Riemann sum. Left Riemann sum uses the very first value, and it's going to stop one. So this is the last value. I'll just put xn because xn will be the last, and then minus one change in x, because it won't get to the last value. Right? We have to decide which side of the rectangle to use. This one's going to use the left side. So here we have a problem that's coming up any day now. There we go. And so remember, on the left-hand side, we're going to use, so f of x naught's the first value, and then the second value would be the first value plus the change in x. The second value would be the first value plus the change in x. The second value plus the change in x. The third value would be the second value plus the change in x, and so forth and so forth. And just like before, the things we need when using a left Riemann sum are exactly the same as for a right one. We need to know the endpoints. We need to know how many intervals. We need to know the function. We need a table. We need a graph. We need the equation. One of those things.
Just one? Table, graph?
Yeah, just one of them. Because we can get the rest.
Okay. Well, it's easier if we have all of them.
Well, if we have a table, we're going to calculate it a different way. All right, so here we have x cubed. Our starting value was 0. Our ending value was 4 subintervals. This one's a pretty easy one. So our change in x is just 4 minus 0 divided by 4. It's 1. So I even have the numbers up there. All right, so here's our graph. X cubed is kind of an S. Since we're starting at 0, so it would just look like kind of like that. And then the other side would be the other half of the S. So we want 0. And then our change in x is 1. So each of these rectangles is going to have a width of 1. Whoops, and we're a little bit crooked here. 1, 2, 3, and 4. I should make this a little fatter. I should make my table and then make the graph to represent it, right? Because the other side would look like this, right? But we don't really need it. All right, so now we draw our rectangles, but we're drawing from the left-hand side. So that means that the very first rectangle is going to have a very short width. And then we have our second rectangle. Boy, this is really crooked. And our third rectangle. And our fourth rectangle. So our values for a first rectangle, I said it's short, right, because f of 0 is 0. So the very first rectangle has a height of 0. The second rectangle uses f of 1. It's always using the left-hand value, so it's using these values here. So the second rectangle will have a height of 1. The third rectangle will have a height of 8, and then the last rectangle will have a height of 27, because we're using 0, 1, 2, and 3, and we don't use f of 4. So really super easy one here would be 1 is the change in x times 1 plus 8, excuse me, 0 plus 1 plus 8 plus 27. For some reason I put in 81. 0 plus 1 plus 8 plus 27, which means our area here is going to be 36. So that was a really easy one. Those coming in got to see a really, really easy one on the left Riemann sum. Did I put that one in the notes or no?
Yes.
I did.
Also, if it's in there already.
Yeah, it is.
Why is it called the left one?
Because you're using the left endpoints.
So I have 2 questions for you. One, I missed that test you took yesterday. When did you review it?
As soon as you can, or I don't know when you're leaving, but
And then 2, when do you have tutoring next?
Wednesday.
Wednesday.
Come on.
Oh, that stupid blue dot next to the 1 is on our notes.
Oh, sorry.
You're gonna erase it there, but it will still.
It's still on the paper.
It shall always be burned onto the paper.
You have to use a whiteout.
We'll just like tear out small pieces.
During the podcast, you're going to hear Spanish music.
They're just gonna hear me just eating goldfish the whole podcast.
Here's our next one coming up. The one in your notes is 3 sine x. Let's see if it's the one up here. I have another one. Yep, 3 sine x. All right, so change in x is going to be our ending value is pi minus our starting value divided by the number of intervals. So pi 6 is our interval. I tried making this really wide so we have space. So I'm at number first this time. Try something new. All right, so we're starting with pi 6. All right, so the next one would be 2 pi 6 or pi thirds. So each time we're going up by a 6. And then we have 3 pi 6 or pi halves. And then 4 pi 6 or 2 pi thirds. And then 5 pi 6 and then pi. Okay, so sine starts at 0. Okay, and then we want to draw our graph, right? So let's get a couple key values here. So sine 0. That's going to be, and this is 3 sine of x. So 3 sine of x is still going to be 0. Let's try and draw this a little bit accurate. Sine pi, that's also 0. And so it's going to, this whole time it's going to be up above. Right? And then after pi it would go below, right? And the 3 is not going to change that. Just changes our altitude. So that's a good enough graph for this. Let's draw in our rectangle. So we're using left side. So this is going to be the first one, big height of 0 there. The second one is going to start at pi 6. So when pi 6 hits the curve, we stop. When pi thirds hits the curve, we stop. Oops. When pi halves hits the curve. When 2 pi thirds hits the curve. So I'm going to go out of the boundaries here. Oops. I missed the line totally. My hand is blocking. And then 5 pi hits the curve. Oops. And there we go. And notice we don't use pi.
Is it not supposed to be out of the circle though?
Nope. What is whatever the rectangle is. Yeah, whatever the rectangle is. And so we're using 0, pi 6, pi thirds, pi halves, 2 pi thirds, 5 pi 6. Not pi.
Two representations
Okay.
actually.
So we have, yeah, it's just trying to represent our rectangles. So we have 3 sine 0 is 0. 3 sine pi 6. Right, so here we can draw that out. Right, pi 6 is over here. So pi 6 is the same as 30 degrees. 1 is over here. Square root of 3 is over here, and 2 is over here. So that's going to be a half. Excuse me, 3 halves, because we had to multiply by 3. So 3 times a half. Just 3 halves. And then we have 3 sine pi thirds. Almost the same, except now that's a 60 degrees. This is the square root of 3 over 2. So that's going to be 3 times the square root of 3 over 2, which is, well, 3 square roots of 3 over 2. Then we have 3 sine pi halves. Oops, I don't know why that put a 4 there. All right, so pi halves is right here. So that's just 3 times 0. I mean, excuse me, 3 times 1, which is 3. 3 sine 2 pi thirds. All right, so 2 pi thirds is over here. All right, and so this is still going to be the square root of 3. And this is going to be 2, and it is positive. because the y is positive. So 3 times the square root of 3 over 2, or 3 square roots of 3 over 2. And then we have 3 sine 5 pi 6 is the last one. And that's over, we'll just use this graph over here. So same triangle, 1 to square root of 3. It is positive because the y is positive, so 3 times 1/2, or 3/2. All right, so now our area is going to be our change in x, which was pi 6, times 0 plus 3/2 plus 3 square roots of 3/2 plus 3 plus 3 square roots of 3/2 plus 3/2. Let's see what we can add here. All right, so the 3/2, 1.5 plus 1.5, that's 3, and that one there is 6. So this one is 6 plus, and then we've got 6 square roots of 3 over 2. We're just going to keep this as the exact answer. So we may as well distribute that. So area is going to be, well, the 6's will cancel. So this is pi plus, and then the 6's will cancel there. The square root of 3/2 is our area.
Neat.
I guess we'll skip the closing for today, but we will have a closing tomorrow.
Right.
That's 4.37.
We'll make it a big closing.
Maybe a 30-minute closing.
No.
Not that big.
Just 29.
Did we get out at 57?
Yes. So we have 1
Right?
minute.
1 minute. All right, so tomorrow in class, we're going to pick up with this problem here as soon as it changes. It's probably introduction to midpoint Riemann sum.
Yes, it is.
There we go. So we're going to look at tomorrow the midpoint Riemann sum. And we're also going to be looking at tables with Riemann sums. All right, bye for now.